Okay, let's get started on 2.4 using linear models. So, two objectives here in this section. One, to write linear equations that model real-world data. So in this situation, we're going to be coming up with equations like y equals mx plus b. We have more options than that, but we're going to be using actual data instead of just made-up numbers. All right, and then we're going to use that data to make predictions from those linear models. So remember, a linear model is just something that makes a line. So an equation that makes a line could be y equals mx plus b, could be y minus y1 equals m x minus x1. Do we remember what that one's called? If you said point slope, good job. All right, just a reminder, skills check. Make sure you try those. And then two new vocab phrases, scatterplot and trend line. We'll jump into those in just a few minutes. All right, modeling real-world data. You can write linear equations to model real-world problems. Let's check one out. Jacksonville, Florida has an elevation of 12 feet above sea level. A hot air balloon taking off from Jacksonville rises 50 feet per minute. Write an equation to model the balloon's elevation as a function of time. Okay, so we're talking about functions in terms of time. So that's our key word in here, key phrase. We're going to write a function in terms of time, which means that if we know what the t is, we can figure out what would the output be? If you said height, elevation, good. The output is going to be elevation. We pick time, we get elevation. So what would we have to do? We're going to look for two things. We're going to look for constants, and we're going to look for multipliers. So first, let's see if we can find a constant. 12 feet is where we start. We're starting at a constant of 12 feet above the ground. So we'll put in a 12. And, so plus, we're rising at 50 feet per minute. So 50 times t. Every minute we times by 50. So we would probably rewrite this. So it's f of t equals 50t plus 12. So now we can graph this equation. So we would have an intercept of 12. I'm going to count by 10. So 12 would be right about there. And we're going to go up 50. So 10, 20, 30, 40, 50. So let's see, 10, 20, 30, 40, 50, and over 1. And I want you. We would connect those, and we'd have the graph of our line. Interpret the intercept at which the graph intersects the vertical axis. So here's our intercept. That's going to be our initial height. So the intercept, the y-intercept, is always your initial whatever the output value is going to be. In this case, it's height. All right, so you give that a shot for understanding check number 1. All right, for 2, what if we had 2 data points? We didn't have a constant, but we had 2 x's and 2 y's. So in this case, a candle is 6 inches tall after burning for an hour. We have a relationship. We could do a little t-table here. X and y, or we could call this, we could say height, and actually height would be your output. How tall is it after burning for an hour? Time. So time was an hour, height was 6 inches. Time is 3 hours, height is 5.5 inches, so 5.5. All right, write a linear equation for this. All right, so we have 3 different types of equations. We've got y equals mx plus b. We've got y minus y1 equals m x minus x1. And we have standard form, but we're not going to use standard form usually ever to solve ax plus by equals c. You're going to come up with standard form after getting the numbers. So we were really only going to use these 2 forms. All right? And since we have points, let's go ahead and use point slope. The problem is we don't know slope yet, so we're going to need to find that. M equals y1 minus y2 over x1 minus x2. So we get 0.5 over -2. And we don't want to have decimals in a fraction, so let's times by 2. So we would get 1 over -4. So there's our slope. And let's plug in some points. Y minus, let's go ahead and use 6 so we don't have to deal with the decimal here. Y minus 6 equals -1/4 x minus 1. And then if we wanted to, we could move it into this form. We don't have to because it just says write a linear equation. It doesn't say slope-intercept. But if you really love slope-intercept, you can say y equals -1/4 x minus 1 plus the 6, if we add the 6 first. Let's distribute. So -1/4 x plus 1/4 plus 6. And so then we'd have y equals -1/4 x plus, this would be 25/4. Okay, so if you really love getting into that form, great. Otherwise, perfectly fine to leave it just like this, because that is a linear equation. Go ahead and try it for understanding check number 2. All right, let's use a linear model. Okay, so if you did it correctly, followed me along, this was the equation we got. Oh, ugly, ugly, ugly. 25/4 instead of 6 1/4. All right, when will the candle be 4 inches tall? That's what we're trying to figure out here. So again, we need to figure out, is this the input or the output? If we look back, the time was our x and the height was our y. So this is going to be a y value. You're going to plug in 4. 4 equals -1/4 x plus 25/4. Okay, so why don't we multiply everything by 4 to get rid of the fractions here? So 16 equals -x plus 25. And let's minus the 25 and get -9 equals -x. And so x equals 9. So it would take 9 hours to burn down to 4 inches. Now, will it take 9 hours exactly? Probably not, but this is an estimate. We're going to use this to model it. So modeling means make a prediction. So we don't think it will happen in exactly 9 hours. It might. Predict. I was talking while I was writing. Prediction. There we go. All right, it might happen in 9 hours, but we're going to say it's a pretty good guess that it will happen in 9 hours. That's our linear model. Try problem 3. Okay, last section here is about scatter plots and trend lines. So scatter plot, a graph that relates two different sets of data by plotting the data as ordered pairs, x's and y's, right? And then once we have them all, we want to look at it to see what kind of relationship we have. So we have something called correlation. Two things with correlation, weak versus strong. If all the dots are tied together closely, you have strong correlation. So we have strong correlation here and here. And then weak is if they're kind of spread out, spaced apart, right? There's not a tight grouping. Positive means that they're kind of trending up. Negative means they're trending down, right? So we're looking for strong versus weak, and then positive versus negative. And then we might have one where the dots are just all over the place. There's no kind of pattern going on, so there's just no correlation at all. So correlation is your pattern between the x's and the y's. A trend line is a line that approximates the relationship. So if these were your actual pieces of data and we had to predict, we might draw a line like that and say, you know what? If x was over here, I would bet that my y would be way up here. If my x was right here, I would bet that my y would be right about there. Right? I'd have a dot on the line like that and like that. All right, let's try one of these. So, a woman is considering buying the 1993 car shown in the photo. You can look in your textbook for the photo. She researches prices for various versions of the same model and records the data in a table. Okay, so we have a whole bunch of information here. Let X represent the model year. Use 4 for 94, 5 for 95, etc. Y be the price of the new car. Let's draw a scatter plot. Okay, so I'm going to pause this for a second and bring up our graphing calculator and show you how to do it on the graphing calculator. We'll do this on Desmos in class. Okay, so follow along with these steps and also when you do it for yourself. So we're going to go in here to our stat. So stat for statistics, and we're going to make ourselves a list here. So let's go ahead and go into edit. Okay, and I'm going to clear this one off. I'm going to hit clear and enter. Oops, go up to the top, clear, and hit enter. That'll clear your whole list. Up to the top, clear, and hit enter. Okay, and so now list 1 is going to be your x's, list 2 is going to be your y's. So I'm going to put in 4. Ah, don't want that. Clear. 4, and hit enter. All right, and so 5784. would be over in my y. So let me move you on over. There we go. 5784 and hit enter. Okay, so we've got those. Let me pause this for a second. I'm going to type these all in and see if you can get yours typed into your calculator as well. Okay, just like magic, we're all typed in here. Notice how there's 2 numbers for year 8, 2 numbers for year 7, right? We're in here. All right, to plot this, we're going to go first to our window. We're going to change our viewing window. So what's the smallest x that you had? The smallest x is 4. So I wanted my minimum to be just a little below that. I'm going to pick 0. What's my biggest x? My biggest x was 8. So I want my x max to be a little above that. I'm going to go with 10. Let's skip scale for now. We'll come back to that. My smallest y was in the 5,000s. So I'm going to go a little below that for my y min and say 5,000. And my biggest one was 10,000, so a little above that would be 11,000. Again, if this is confusing, we're going to go through using the calculator in class again. Okay, you can pause the video, watch it a second time if you need to. But at this point, now I'm going to go into my y equals. I'm going to clear off any equations and turn on plot 1. Plot 1 is for scatter plots. I'm going to hit enter and hit graph, and there we go. There's all of our dots graphed. All right, there's our scatter plot. Is a linear model reasonable? Absolutely. You could draw a line through that. Okay. And then for a trend line, we could come up with the equation. I'm going to pause for now on that, and we're going to go through that in detail in class for the trend line. Okay. So don't worry about coming up with the trend line. We will worry about that in class. But for your understanding check, graph these and then decide whether the linear model is reasonable. You can either graph these by hand or try using the graphing calculator, and then we'll go over that in detail again in class. All right, that's it for this section. Good luck on all those questions. Make sure you put them in the Google form, and we'll see you in class.